All right, good day, everyone. Today, what we're going to be going through is operations with complex numbers. Now, yesterday we talked about basically how to add in some complex numbers, right? We took those values, we combined them together, kind of like terms. Well, in today's lesson, we're going to be talking about multiplying and dividing, okay? Which the actual math behind it is going to be very similar to what we've done in the past, okay? It's really not going to be much different. Really, in this lesson, the big thing we're going to have to understand is how to FOIL. Okay. This example B right here is actually a great thing to start with and actually look at, because notice the math behind each of those. Notice how in this first one right here, we have 2 plus 3x times 4 minus 5x. They take the 2 and multiply it to both the 4 and the 5x. And they also take the 3x and multiply it to the 4 and the 5x. Okay. Basically what we've done in the past. Well, if you look at the other example here, it's kind of the same process where we take the 2 times the 4 and the negative 5i, as we see here. And then we also take the 3i and times it by the 4 and the negative 5i, as we do here. So our math is literally going to stay the same. There really is no differences when it actually comes to our mathematics. Here's where it slightly changes, and this is where it comes big for actual I squared or actual I values. I squared actually equals -1. And that is a key idea to remember. The reason is because if you look at this example, at this particular spot, we have 15I squared. Well, notice how they say now substitute -1 in for I squared. Well, because of that, this becomes -15 times -1 or positive 15. So if you're wondering how they got 23, it's because they had 15 plus 8 gave me 23. Okay? So anytime you have an I squared, it actually flips the sign of the number you're dealing with. So let's go ahead and talk about basically how to go through them. Let's do one fresh. If we talk about letter A here, we have 6 plus 5i being multiplied 4 minus 7i. To do this problem, we're going to basically consider FOILing. 6 times 4, 6 times 7i. Basically, we have to multiply the 6 to both those values. 6 times 4 is 24. 6 times -7i is negative. 6 times 7 is 42. And the I carries down. We then repeat the process with the 5i. Multiply that number through. 5 times 4 is positive 20i. 5 times -7i is -35, and then since we have an I and an I, it's going to become I squared. Okay? Now, at this point, we're going to combine like terms, but this is where the key concept comes in. I have an I squared currently sitting right there. Well, I squared is equal to -1, as we see right here. So what I'm allowed to do is plug in a -1 for I squared. Well, what that's going to do is flip the sign of what I currently have. So 24 minus 42, I plus 20i. And then if this value was a -1, what it would do is flip the sign and go away. Okay, because it's -1 I squared equals -1. -1 times a -35 would be a positive 35. From there, I'm just going to simplify my values. Okay? And sorry about that, I got a bunch of dots on the screen. Let me get rid of those. At this point, I'm just going to combine like terms just like we did yesterday. 35 plus 24 is going to be 59. -42 plus 20i is -22i. And I have my answer. And that's kind of the process that we have to think about. In all honesty, it is literally just FOILing. Math we've done before, math we've seen. Okay, we've definitely worked those problems out where we've had to FOIL out before. The only difference now is that within these problems, while I'm FOILing, I have to look for that I squared and be able to simplify that value out. So with that being said, how do we actually handle a division problem? Because this is where it gets a little bit different. We got to be able to talk about what's a division problem going to do. Well, to do a division, we have to understand what a complex conjugate is. Okay? A complex conjugate is this idea of if I take a 2 plus 3i. The exact opposite or conjugate of it is going to be a 2 minus 3i. Well, let's see what happens when I actually work that out. If I were to take a 2 minus 9i and multiply it by its conjugate, which is 2 plus 9i. Okay, notice how all I do is flip the actual operation. If I multiply this out, something very interesting happens. We multiply the 2 through to get 4. 2 times 9 is positive 18i. Then we multiply the negative 9i through. Negative 9i times 2 is going to be negative 18i. Negative 9 times positive 9i is going to be negative 81i squared. Well, look what happens to your two middle numbers. We have a positive 18i, negative 18i. Those two values are just going to cancel each other out. They're going to basically become 0. On top of that, I squared is really negative 1. So that's going to flip my 81 to be a positive, meaning this is going to be 4 plus 81. Oops. 4 plus 81, which comes out to be an answer of 85. So if I multiply by that conjugate, it actually cancels everything out for me. Okay? So now let's apply this idea to our actual math. The reason why this is important is because we need to find a way to actually get rid of an I value, okay? If I wanted to get rid of an imaginary number, I can look there and say, okay, I need to have its complex conjugate to do that. Well, that kind of leads us right into division. In division problems, what we're trying to do is we're trying to get rid of the I on bottom. We don't want that I on the bottom portion. So this value becomes pretty straightforward. I'm going to take 4 minus 5i divided by 2 plus 3i. But to get rid of this bottom I value, I have to multiply the bottom by its conjugate, which is 2 minus 3i. Well, whatever we do to the bottom, we also have to do to the top. We have a 2 minus 3i in bottom. We're also going to multiply the top by 2 minus 3i. And what happens is this becomes basically a two-step problem. I have to multiply the top, which is 4 minus 5i, times 2 minus 3i. And I have to multiply the bottom, which is 2 plus 3i times 2 minus 3i. Okay? So let's go ahead and work these out. If I multiply the top out, multiply the top function out, I would multiply the 4 through to get 4 times 2, which is 8, 4 times negative 3i, which is negative 12i, and then multiply the 5i through. Negative 5i times 2 is negative 10i. Negative 5i times negative 3i is positive 15i squared. At this point, I simplify. This becomes 8. Negative 12 minus 10 is negative 22i. And then 15i squared, simplified, is going to be negative 15. Combine 8 and negative 15 together, you get negative 7 minus 22i, which I can write on top. Negative 7 minus 22i. Now the only difference is I have to simplify the bottom function. We go ahead and do the same thing. We multiply the 2 through. 2 times 2 is 4. 2 times negative 3i is negative 6i. And then we multiply the 3i through. 3i times 2 is positive 6i. 3i times negative 3i is negative 9i squared. The middle values are going to cancel out, and the I squared is going to become positive, meaning we have 4 plus 9, which gives us 13. That was our answer to the bottom. And now that we've done top and bottom, we get to our final answer. Notice how in this problem, really a division problem means we're doing zero division, okay? The only thing that we're doing in this problem is we're foiling multiple times. The difference is we have to know what to FOIL, and that comes from finding the conjugate of the bottom so that it cancels itself out. Okay? We'll be going through more of these in class tomorrow. Answer any questions around the Edpuzzle, but besides that, have a great day, and I will see you tomorrow.